Alright, hello again everyone. Welcome back. Today we're working on our 5.9 RSG notes. So the last couple days in 5.8 you've been working on systems of equations. And so far all you've done is write a system of equations. So like a quick look back at that 5.8 RSG. You read a word problem, you defined two variables, and the word problem helped you write these two equations. That's a system of equations. What we haven't talked about yet, though, is how to solve them. So, like, now that we know that the number of hamburgers and the number of sodas makes a total of 24, and that $2 per hamburger plus $1 per soda makes a total of $40, we're left wondering, okay, but how many hamburgers was it, and how many sodas was it? And so today, in 5.9, we now turn our attention to the answers of a system of equations. So let's go ahead and get started. Beginning with a reminder of what is a linear system, a system of equations. Well, it's a set of two or more equations with the same variables. So there again is another example of a linear system, a system of equations. Two equations that use the same variables. So now the big deal today, well, what is a solution of a linear system? The solution to a linear system is an ordered pair. So like x comma y, ordered pair of numbers that satisfies, that means it works for both equations. So imagine what we know about linear equations. Just take this top one, x plus 2y equals 7. We know that that would make a line on a graph, and that line has infinite points, that there are infinite x, y combinations, x, y ordered pairs that you can put in here to make this true. Well, then the same is true of this one. This would make a line, a different line, and it would have infinite x, y points that work for this. All those points on the line are all x, y values that work here. So while there are infinite x, y's that work for this, and infinite x, y's that work for this, we're trying to find, are there any that actually work for both of them at the same time? So let's go ahead and start by checking possible solutions. So like here is a linear system. Here is possibly the solution. Maybe it's 4 comma 1. Let's check. And we can do that by putting x is 4 and y is 1 into each of those equations. So I'm going to start with the top one right over here. That's x plus 2y equals 6. And I'm going to put x is 4 plus 2 times y is 1. And 4 plus 2 times 1 is 2. Of course, 4 plus 2 does equal 6, and that works. So far what I know is that ordered pair is a solution of the top equation. But to be a solution of a linear system, it needs to satisfy both of them. So now I'm going to work on the bottom equation, and that was 3x plus y equals 11. Well, x is 4. 3 times x becomes 3 times 4, plus y is 1, equals 11. 3 times 4 is 12. 12 plus 1 is 13. Now 13 equals 11 is not true. So what I now know is that the point 4 comma 1 is a point on that line, but not on that one. And that means this is not a solution. So I'm going to do the next one a little bit quicker, but ultimately the same idea. Take your top equation and replace x with negative 2 and replace y with 1. And then evaluate to see if that actually fits together. 5 times negative 2 is negative 10. Negative 2 times 1 is negative 2 or minus 2. And of course, negative 10 minus 2 does equal negative 12. So far so good. The first one works, but remember it has to work for both of them. So I come down to the second one, x plus 3y equals 1. I replace x is negative 2 plus 3 times y is 1. Negative 2 plus 3 does equal 1, and that works. Well, now what I can tell is that that point is on the first line. It is also on the second line. It satisfies both equations. That's a solution to the system. I'm going to leave the third one as an optional. You can try it if you want, but we're going to move ahead and look at some other stuff now. So down here for numbers 1 and 2, now we're actually solving ourselves. So instead of here where they suggested maybe this is the answer and we just check to see either no it's not or maybe this is the answer and we check to see yes it is, well now we're actually going to find the answer ourselves. And we're going to do that using a graph. So knowing that this equation makes a line with infinite points, knowing this equation makes a line with infinite points, we're looking to see, is there a point that works for both of them? So we're going to start by graphing them one at a time. So I'm going to call this first one equation 1. And that's m equals negative 1/2. That's going to go down and right. It's also b equals 2. So that's for equation 1. So I'm going to start at a y-intercept of 2. And then I'm going to go down 1, right 2. And down 1, right 2. And I'm going to do that repeatedly. Then I can even go the other way. I can go up 1, left 2 a few times. And then ultimately, you know, with a ruler if you want, or just be really careful, go ahead and draw your straight line that goes right through all those points. So now I want to work on the second equation. So I'm going to put a little number 2 there, call that equation 2. And right here I'm going to do equation 2. Well, equation 2 had a slope, m equals 3/2. It also had a y-intercept, b equals, that's a negative 2 that time. So now I'm going to start at negative 2 and go up 1, 2, 3 over 2. That's up 3, right 2. And do it again, up 1, 2, 3, right 2. There it is. Now when I connect those and draw that line, what I notice right away is these two lines intersect each other. So remember, if this line represents infinite solutions to equation 1, and if this line represents infinite solutions to equation 2, we're looking for, is there a solution that represents both of them? And sure enough, that point right there, it's part of the line for equation 1, it's part of the line for equation 2. It is the solution. It's over 2 up 1. So that's a solution of 2, 1. And we found it because it's the point of intersection. So graph two lines, find where they intersect, and you've found the solution to your system. Let's practice that one more time. For this problem, I noticed neither of them are written in slope-intercept this time. So I'm going to take equation 1, and for equation 1, I see it's in standard form. I might want to work on this with intercepts, and I can do x equals 0, find the y-intercept, y equals 0, find the x-intercept. I'm instead actually going to take the negative x and move it to the other side, because then I can make this slope-intercept. I'm going to do a plus x right there, and a plus x right there. Leaves me with y equals x minus 7. I took the positive x up front, the negative 7 in the back. Well, now I have m equals 1. That's 1 over 1, up 1, right 1, while b equals negative 7. So starting down at negative 7 and going up 1 over 1, up 1 over 1 repeatedly. And you can get a sense of that line and where it's going. And all those points are answers for that equation. Well, for equation 2, it is in point slope form. So I'm going to say that there is a slope of negative 1/4, and that's going to go down and to the right. There is a point, remember, it's always supposed to be x minus. So the x, the minus, that's supposed to be there. This is an x value of 8, and then 8, negative 4. And that's where we start. So I'm going to start at 8, negative 4, go over 8, and down 4. Put a point right there to start. Now for my slope to go down 1, right 4, down 1, right 4, I'd run right off the graph. So I'm going to reverse that. I'm going to go 1 over negative 4, up and left. Now when I go up 1 and then left, 1, 2, 3, 4, sure enough, I land on top of an old point. I'm going to do it one more time. Up 1 and left, 1, 2, 3, 4. And when I connect those and graph that line, you notice the point of intersection right here at over 4, down 3. That's 4, negative 3 is the solution, and that's the point of intersection. So now the last thing that we work on today is bringing it back to 5.8, which was all word problems. And it's, so how do we use a system to actually answer a word problem, to make sense of that answer? So a description, an explanation of a word problem, a description of what both the x and y represent. We're going to cross this one out. We don't need to do this other step and say what the conditions were. I think as long as we say what is x telling us and what is y telling us, then we're good. So take a look at problem 3 here. And this problem, it sounds a whole lot like the problems you worked on in 5.8. So you're buying pizzas and breadsticks. Pizzas are $8 each, breadsticks are $6 each. We know a total of $64. We know a total of 9 items. Back in 5.8, you would have written this system yourself. That x plus y equals 9. That's the number of pizzas plus the number of breadsticks equals 9. And that 8x, $8 per pizza, plus 6y, plus $6 per breadstick equals 64. There's that total of $64. So this is something you would have worked on in 5.8, and you would have written that system and then stopped. Well, what we can do now is actually solve the system and figure out, so how many pizzas and how many breadsticks did they get? So the line for x plus y equals 9 represents all the ways you can get 9 items. It could be 0 of these and 9 of those. It could be 9 of these and 0 of those, or anything in the middle, 7 and 2, 6 and 3, 3 and 6, etc. This represents all the ways that you could spend $64. Maybe you only spent your money on pizzas. Well, that would be right here. That would be, I got 8 pizzas. 8 times 8 is 64. 0 breadsticks. That's possible. But that's only 8 items. 8 pizzas, 0 breadsticks. We know it needs to be 9 items. So by graphing one equation and finding all the ways to spend $64, graphing the other equation and finding all the ways you can get 9 items, we find a point of intersection that satisfies both. And here they did it for us. They graphed it and they found that point of intersection is 5, 4. What does that tell us? If x is 5, that tells us you can order 5 pizzas and if y is 4, and 4 breadsticks. And that is 5 plus 4, that's 9 items. And sure enough, $8 each here, so that's 8 times 5 is 40. $6 each here, that's 6 times 4 is 24. 40 and 24 makes 64. So this is how you can get 9 items and spend $64 with 5 pizzas and 4 breadsticks. So next one, we're going to do it a little quicker at this point. It's all the same idea. Read the problem. It's a system like you would have written in 5.8. Check how they graphed one, graphed the other, and found the point of intersection, this time at 30, 8. Well, since x was the number of students on a bus, and since y was the number of students in a van, this tells us you can fit 30 students on each bus and 8 students on each van. And that's it for today. So for today, you're done. All you have to do is please take a picture of both of these pages, pages 44 and 45. Go ahead and upload them to today's assignment in Google Classroom. Thank you very much.